This is an introduction to right triangle trigonometry. We want to talk about the parts of a right triangle. A right triangle has a right angle, that's the 90-degree angle. And we use uppercase letters when we name the angles. Many times we'll use A, B, and C, and in that case angle C will be the right angle. The letter A and the letter B are used for the other two angles, but their position is optional. Those two letters could be switched. They're simply the two angles which are not the right angle. Furthermore, the angles which are not the right angles are the acute angles, meaning they are less than 90 degrees. Now the side opposite the right angle is called the hypotenuse. The other two sides are called the legs. We name the sides with lowercase letters. Here's angle C, that's the capital C, and opposite is little c, which is the length of the side opposite angle C. And across from angle A we have little a, that's the length of that side. And across from angle B we have little b, and that's the length of this side across from angle B. Now, it doesn't matter how the triangle is oriented, and it doesn't matter what letters you're using, the hypotenuse is always directly across from the right angle. We're going to be naming the legs either the adjacent or the opposite, but this entirely depends on which angle we specify. We're going to start by specifying angle P, and the opposite side would be across from angle P. So there's the opposite side. Now adjacent means next to, so the side which is adjacent to angle P is the one which is next to angle P, but not the hypotenuse. So here's angle P right here, and there's really two sides which are next to it. Those are the two sides which make the angle. We're going to choose the one which is not the hypotenuse, and that's the adjacent side. Now if we switch to angle Q, here's angle Q, now opposite and adjacent is going to change. So the opposite is directly across from angle Q, and the side which is adjacent to angle Q is right next to angle Q. So again, opposite and adjacent depend on which angle we're talking about. Test yourself. Try to answer the question before we state the answer. So here you have a triangle with three sides. Which one is the hypotenuse? Name the length. Give the number of the length of the hypotenuse, and that's 70. Now what about the side which is opposite angle B? Here's angle B. Which side is opposite angle B? That's 15, directly opposite angle B. Now the side opposite angle A, here's angle A. What's the length of the side opposite angle A? There it is. That is the side opposite angle A. The length of the side adjacent to angle A, remember, we really have two of them that are adjacent, but we want to choose the one which is not the hypotenuse, so that is 15. The length of the side adjacent to angle B, here's angle B. Which are we going to say is the side adjacent to angle B? What is the length of the side? And that is 8. We're going to be working with three trigonometry functions, and they're called sine, cosine, and tangent. For each one, the input, what you put into the function, also known as the argument, is going to be one of those acute angles. One of these angles which is less than 90 degrees. One of the acute angles will be the argument for these functions. Now these are the abbreviations, and you will see these on your calculator, and we're not using the calculator for this video, but soon you will use your calculator with right triangle trigonometry. So each trig function is defined as the ratio of lengths of sides of the right triangle. So the sine of angle A is the opposite over hypotenuse. Remember, we could put A for either one of these angles. One of these would be angle A, or we could have done it the other way. And from there, we define the opposite and the hypotenuse, and we take the ratio of those lengths. And that is the output for the sine of angle A. Cosine is adjacent over hypotenuse. That's the length of the adjacent side divided by the length of the hypotenuse. And tangent is the length of the opposite side divided by the length of the adjacent. Now some people memorize these by this funny little saying here, SOHCAHTOA. Of course you need to make sure you spell it correctly. This is just to remind you that sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So let's try this one. We want the sine of A, so I'm interested in opposite over hypotenuse. Here's A, so I'm looking for the side which is opposite angle A, and that would be 8 divided by the hypotenuse, which is 17, and that's the answer to the sine of angle A. Let's try cosine of A. Again, here's angle A. Now for cosine, we want adjacent, the length of the adjacent divided by the length of the hypotenuse. So for angle A, there's the adjacent, and so this will be 15 divided by 17. And now for the tangent of A, here's angle A. This time we want the opposite, the length of the opposite divided by the length of the adjacent. Here's my opposite, here's my adjacent, so this is going to be 8 divided by 15. So there you can see that we have now answered the question for the sine, cosine, and tangent for angle A in this particular triangle. Here's another case. Try this for a minute, see if you get all the right answers here. Just put it on pause and jot down your answers. So sine of B is going to be my opposite, which is 15 divided by 17. Cosine of B, I'm using my adjacent, so that's 8 over 17. And the tangent of B is my opposite over adjacent, so that is 15 divided by 8. You should check to make sure your fractions are reduced. These are all reduced, so that is not a problem. They're all considered simplified. Now, this is an interesting problem. It looks very similar to the one before, but notice we are missing a side here. And namely, what are we missing here? We're missing the hypotenuse. Let's call this x. We're going to need to find x. We're going to use the Pythagorean theorem here. A squared plus b squared equals c squared, where c is the hypotenuse. I have 2 squared plus 3 squared equals c squared. And as I solve this, I'm coming up with a length of c. Now, by the way, normally when you take the square root, you would get plus or minus. But in this case, because we're talking about the length of a side, we only use the positive square root. So I've now found the missing side is the square root of 13. For the sine of A, I need the opposite divided by the hypotenuse. So in this case, here's angle A. I'm looking at the opposite. That would be 2 over radical 13. Now, I need to do more because I'm not allowed to keep this square root in the denominator. So in order to get this square root out of the denominator, I need to rationalize the denominator, multiplying top and bottom by the square root of 13. And I come to my answer here, 2 times the square root of 13 divided by 13. That is the sine of A. Let's try the cosine of A. So for the cosine of A, I'm looking at adjacent divided by hypotenuse. And you don't have to write this every time, but I'm doing it to let you know where I got these numbers from. So my adjacent, the length of my adjacent is 3, the length of my hypotenuse is 13. Once again, I need to rationalize that denominator. So I'm rationalizing the denominator here, and I end up with my answer, 3 radical 13 over 13. Here's my answer for the cosine of A. Now for the tangent of A, I'm still using angle A. This time I need the opposite divided by the adjacent. That's the OA, if you remember SOHCAHTOA. And so opposite here, let's see, there's angle A, there's my opposite, is 2, adjacent is 3, and look at that. I don't have to simplify that, that is my answer. The tangent of A is 2/3. Now in this problem, they're giving us some information. They tell us the length of the hypotenuse. They tell us what one of the sides is, and we have to find something. Really, you need to make a diagram. So you should make a triangle, and then you need to put some angles on there. There's my angle A, and I really need angle B as well. Now I can fill this information in. My hypotenuse is 13. Side B, remember that's opposite angle B, Side B here is 5. Now before I go any further, I'm going to need to find this missing side. And once again, I'm going to set up the Pythagorean theorem here. A squared plus b squared equals c squared. So in this case, this is a squared plus 5 squared equals 13 squared. And I'm solving this in order to find our missing side here. And I get down to a squared equals 144. When I take the square root here, I'm only using the positive square root because this is the length of a side and it really can't be negative. So, I have found this missing side. And now let's see, what are they really asking me for here? This is a lot of words, but what they're really asking me for is the sine of A. And recall that's opposite over hypotenuse. I just need to fill in those sides here. Here's my angle A, there's opposite, so this is 12 over 13. And that brings me to my answer. The sine function of angle A is the ratio 12 over 13. A fraction is a ratio. That's 12 over 13.